Okay, so 1.14b, this is our last section. And I do want to make sure you realize that the test is actually, because I want to be able, there's a couple people who really could use a little boost in their grade. So it's going to be quarter 1, test 3. This will count in third quarter. I think quite a few of you are hopefully pleased, because I do think that this section is kind of one of the easier things we've done for most people, and so that way this could be like an easy test grade to bring up our test grades, and the people who already have grades that they're comfortable with will still do well on the test, so you'll be okay. But this is for our friends who need one more test to help get that test grade average, that's 60% of their grade, a little bit higher. Okay, so 1.14b is basically helping you realize and be able to answer correctly the free response questions 1 and free response question 2. The thing that's nice about pre-calc exam is that it's very predictable. They literally are like telling you what is going to be like the free response question 1, 2, 3, and 4. So that's different than like in calculus and in stats. In calculus, like we have like 9 different things our 6 free response questions could be on, but we don't know exactly which of them it's going to be each year. But pre-calc is very predictable, so that's kind of nice. So free response question 1 will always look something like this. It's always going to give you a graph. So here's the graph of f of x. And then it's always going to give you an equation. The equation g is not the equation for this graph. Hopefully you can tell, right? Because g is some rational function. It's not matching that little zigzag piecewise function that we have on the right. So then there are also FRQ 1a. I is always a composite function, which we're going to do way more of next unit. But I think you've done it in geometry algebra too. So let us practice. If we're doing a composite function and we're saying h of x, this is kind of the version of a composite function that I prefer. And we're trying to find h at 3. H of x is some new function. So plug in 3 into that definition. Oh, I'm sorry, I didn't realize you were still going. And you have g at f at 3. So what thing do you think you're going to substitute into first? F of 3. So you're taking 3 and substituting it into f first. That means in the graph of f, you need to find where is this the x or the y value being 3? The x value being 3. So go and find where the x value is 3. So in f, where the x value is 3, the y value is 1. So we're replacing f of 3 with 1. This is very similar to on the 1.12 quiz when you were substituting like p at 6 with whatever p at 6 was equal to. It's the same vibe. So now what are you going to do with the 1?
Multiply times g.
You're not multiplying 1 times g. You're putting it into g. And here's g. So put it in where there's an x value in g. So we're doing g at 1. Which we can do this one pretty easily by hand. 5 times 1 plus 3 over 1 minus 1. So what's happening at 1 for g? There's a vertical asymptote. A g of x would not be defined at 1. So what you say for your answer for AI would be no solution, or you could say undefined, whatever. Oh, it says not defined. So we'll say not defined. That's a better thing to say. Schwitzen. All right, find all the values of x for which f at x is equal to 2. So is the x or the y value 2? The y is 2. So go and take your pencil or pen and draw a line where the y is 2. How many places do I touch? 2. I'm touching at 2 places where it's equal to 2. The 2 places are the x values. So what x values are the y values too? -2 and 4. My and was a little crazy there. If there was no place, like maybe if they said f of x equals 4, there would have been no place where it was 4. So you would have just said no solution or no value. Questions on A? Yeah.
So on A, like the first one, I'm kind of lost on why it's like h of 3 when you're really putting the 3 into f.
Right, so it says that h is equal to this equation.
Mm-hmm.
So I just have to like put it in for where there's an x in the equation that h is equal to.
Okay,
So because h of x is equal to this composite function, a composite function is when you have a function inside of another function. So then I just, wherever there was an x, I'm putting 3.
So if it says like h of x equals 3 of f of x, then it's saying like wherever you put, like if x equals like 5, you can put 5 into both places.
Not both places, there was only one place.
Well, there's 2 x's.
No, there's not, there's only one.
Well, there's 2 spaces for an x.
No, there's not, there's only one. Do you see what it's equal to? This is what it's equal to. There's only one x. So I'm...
H of x, that's why I'm like...
Oh, yeah, I thought you were saying in G. Yeah, so I'm putting there, and then here.
Yeah.
Sorry, I thought you meant into G and F, because a lot of people do that. They like multiply G at 3 times F at 3, and I'm like, no. There's only one place in G of F of X to plug into.
But the h of x is like the same, like the x's are the same.
Yes. Mm-hmm. All right, so on B, find all real zeros of G. So this one could be easy for you to do by hand. I think it is, because we've done rational functions. What do you set equal to 0 if it's a rational function? The numerator or the denominator to find the zeros? The numerator. So we're saying the numerator equal to 0 in a rational function. So you have 5x plus 3 equals 0. X is equal to -3 over 5. Or, I think it's a decimal, -0.6. But FRQ 1 and 2 are calculator allowed. So that's why maybe you get your calculator or your computers out or calculators out. But in Desmos, this would be very easy to find as well. The thing about this question is you can't graph f really, so you do have to understand how functions work. But you can even call, what's nice about Desmos is you can even call it g of x. You can set up a fraction. Numerator 5x plus 3. X minus 1. So we kind of know that there's only going to be one x-intercept because there's only one x in the numerator. Also, there's a horizontal asymptote at 5. So there's only one opportunity for it to cross, and it's going to cross near the origin. But where it crosses, you can just take your finger or your mouse and tap on that dot. Desmos will give you dots, points of significance pretty easily. X-intercepts are points of significance. Maxes and mins are points of significance. Intersections between functions are significant. So this one, you just tap on it in Desmos, and it's like, oh, look, it's at -0.06. That was easy. Or you could solve it by hand. On the AP exam and on the test in this class, you do not have to show the work. So no work is actually required. You can just put the answer on FRQ 1 and 2 because it's all calculator. Except maybe, I think that's not true. This one you have to show the work. But on things like what are the zeros, where are the values of x where it's equal to 2, those, no work really needs to be shown.
So which part of this do we get the graphing calculator?
1 and 2. FRQ 1, all of FRQ 1 and all of FRQ 2.
So like this, like B and C, you could just like have the calculator open to the graph, just look at it.
Mm-hmm. Yeah. All right, so B2, determine the end behavior of G as X decreases. Write your answer in limit notation. So let's write our answer in limit notation first. FRQ 1 was one of the ones I graded last year. I graded 1, 2, and 3. And then the year before that, I graded 4. So these X decreasing without bound, you have to only write the correct limit statement. Like, is it going to infinity or negative infinity? So which one is this one going to? Negative infinity. And then you have to have the correct function. So you can't just say f of x because it's asking for the end behavior of g. So make sure you put g of x in there. Okay, you can look at the graph or look at the equation. As we decrease without bound, what was that noise? If you think about where it's going, I could even put a little graph on there. And as it's decreasing without bound, you see how it's approaching y equals 5 forever and ever and ever, and it's never ever going to cross it. So it's always going to get closer and closer to being 5. Why is that true? Why would it always be approaching 5? Looking at the equation. Angus? Exactly. So there's a horizontal asymptote at y equals 5, which is what either ends are always going to approach in a rational function. Does approach have 2 p's? I think so. Looked weird for a second. So it's always going to be approaching 5 if it's decreasing or increasing without bound. We knew there was a horizontal asymptote at 5 because the numerator and denominator's degrees were the same. So it was a both same, a BS situation. Okay. Questions on B? C. Is F invertible? This is a yes or no question. Is F invertible?
Yes.
Did you find 2 places where the y values were 2? Yeah. So for every 1 input, there should only be exactly 1 output that matches it, and vice versa. For every 1 output, there should only be 1 input for it to be invertible. So this would be no. And the reason to justify, FRQ 1C is always about being invertible. I think there's like one other option. It might be like talking about, I forget what maybe the other option is, but I think it's always invertible. So is it invertible, yes or no? No, because, and the reason can't be it fails the horizontal line test. So talking about the horizontal line test, that's to test if something's invertible or not. This is not invertible. Yes, because it's failing the horizontal line test, but that cannot be the reason you give, because in polar graphs, things don't fail horizontal line tests. Like all of the polar graphs would be failing the horizontal line test, but they're all functions. So we can't say that. You have to say every one input does not have only one output. And you can put and vice versa, I guess. If you feel so called, you can say, for example, x equals -2 and 4. They both went to 2 for the y values. But this is all we're ever going to say. If every one input goes to one output or doesn't go to one output. That's like, memorize that line. That is a line that you will just say on FRQ 2. 1C2.
What does it mean to be invertible?
Invertible means that it's a one-to-one function. So every one input has only one output. So I think I have another example on here. Let's see.
Would it
Like a line would be invertible. This is invertible. I can put a horizontal line through it, and at every place it's only going to touch it one time. A parabola is not invertible.
And what's an inverted function?
An inverted function is one that's like when we switch the x and the y and solve. So like the inverse of a parabola is a sideways parabola, and then it's usually a square root.
Then you have two inputs that give you some.
Right. So like a parabola is not invertible because when I flip it over the line y equals x, now this is not a function because its inverse would not be a function. Yep.
Is g of x invertible?
G of x. Let's look at the graph.
Because I was looking at it. Oh, it doesn't fail the horizontal. I know that you said that's an example.
I mean, like failing the horizontal line test in these situations is a good reason for it to. It's just like what you can't say that's why. You have to just say the input-output thing, but like looking at it, this one would be a function. Or it would be invertible, I mean.
Okay.
Yeah, because I don't see anywhere that the outputs would, like if I drew a horizontal line through it, I'm not crossing two things.
Okay.
Yeah, like the horizontal line test is a good way for you to check. It's just not like a justification that they'll accept on the AP exam. Okay, FRQ 2. Here we have, FRQ 1, mock number 2. Instead of having a graph, we have a table. So whenever you have a table, you should be probably trying to do some kind of regression with it if they ask you to write an equation for it. So let's look though, because let's not get ahead of ourselves. All right. H at x is equal to g at f at x. Find the values of h at 1. Okay, try to find it. I believe in you. Try to find h at 1.
Do all of that.
It's almost like I taught you to get your calculator out. Slow people don't be waiting for me to do this. I know how to do that. It's you and your grades coming up here on this test that need to show we know how to do math. Don't use that sad, pathetic calculator. Oh, you got that one right here. So much better. What are you doing? Use that pathetic thing. Jacob, give that calculator away. That calculator should not exist in your life anymore. We have moved on. You're better than that.
It'll be written like this. I'm assuming it's going to be written like this in the box too.
Mm-hmm.
Yeah, so then if it's written like this, you just have to read it like this. You just have to know that this is what this is.
No, get Desmos out. Give her that calculator. No.
Well, it's just finding.
Get out Desmos because you're going to need it on the next ones.
Well, anyway,
Type in g of x.
for
Into,
this one, at least,
mm-hmm.
this will become one, right? Because because you're looking for you're finding the h at one, where is it? H at one. So it is, the f at one is 6. So then it becomes g at 6, which means a plus 6 and g is 4x. So it'd be 6 to the third times 0.5, or 6 to the second, or 6 squared is at 11. And that would be your answer. Assuming that.
Okay, what was f at 1? Because, right, we're doing f, we're plugging 1 into h and into g at f at 1. What was f at 1? 6. So we really have now g at 6. We're putting that value where there was an f at 1. We're taking the output and putting it in for g. Okay, as long as you've typed into Desmos and called it something other than y equals. When it's y equals, Desmos gets kind of wonky about it. It wants a name. So I just would call it whatever the question called it. So I called it g of x. Then you're going to do g at 6. You should have gotten negative 39.4. You also could use your TI-30XA or TI-30XS or whatever sad little calculator you have in your backpack from geometry. But why?
Wow.
Yeah, you could have typed in 6 and then done 6 cubed times 0.35. And especially the XA is so bad. That little one that you used in Algebra 1, what a terrible calculator. Sorry to be a calculator hater, but that one, you can't see what you just typed like a second ago. And I know that my fingers are sometimes fat, and I don't realize I typed like 4 instead of 5 or whatever, and then my whole problem screwed up. I hate that calculator with a burning passion. The TI-30XS, that's an okay calculator. I kind of like that calculator. Now, in AII, where is f equal 4? 2 and 5. Where is f of x equal to 4? Where the y values are 4. The x values are 2 and 5. Find all the values of x as a decimal where g is equal to 5. Okay, so we already have g typed into our Desmos. What do you think I'm going to do to find where g is equal to 5?
G of x equals 5.
Let's try it. Such an assertive knock. G. So when you type in g of x equals 5, you could have also said y equals 5. It doesn't have to be g of x equals 5. Do you see how there's all these places where it equals? And because g of x is cubic, you know that it's only going to have, if it has 3 x-intercepts, that's the fundamental theorem of algebra. If there are 3 x-intercepts and it's cubic, that's as many x-intercepts as it's ever going to have. This graph is not going to turn back around and intersect 5 again. There's 3 places where it's hitting the x-axis. There's also 3 places where it's hitting 5. Okay, so those are our 3 places. How many decimal places are we rounding to? You couldn't have done that on your TI-30XS, you know what I'm saying? No, you couldn't have, because if you plugged in 5, you were finding the input values at 5 and getting output values. No, it won't work. Not on that calculator. Sad. All right, determine the end behavior as g is increasing without bound. And then determine if it's invertible, and we'll explain why not or why on here too.
Determine the end behavior as lim g of x equals, we have in HA.
All right, Nat, what's the limit going to be for this one? Nat. I don't know what that means.
X
goes to the positive infinity.
Okay. What's the limit going to say?
The limit of gx
And so what's the y values going to? Well, look at your graph.
positive infinity.
Yes.
I said that.
Okay. Is F invertible? Yes or no? No. Why? Right. Here's another variation you could put. Has 2 inputs for 1 output. The 2 inputs were at, what was it? 2 and 5? For when the output was 4. Or you could say it does not have 1 input to 1 output.
Okay, wait. So, but would that mean that like, would x equals 1 be invertible? Because then it would be just y equals 1, which would be a function. Just be a straight line. It'd go from being a vertical line to a horizontal.
Yeah.
So you can have something that's originally not a function be invertible.
Yes. Actually, no, that's not true because it's not invertible. X equals 1 is not invertible because it's already not a function.
Okay.
It has to start out as a function and then be inverted to become a function. All right, here's FRQ 2I. This is what we were doing last class. So the table gives a number of people that are exercising in a large gym. T equals 1, or T equals 0 is 7 a.m. when they open. 84 people are inside the gym right when they open. 5 hours later, there's 21 people exercising inside the gym. At 6 p.m., which is 11 hours later, there's 68 people exercising in the gym. The number of people exercising in the gym can be modeled in a quadratic. Okay, find the model. How do we do it?
Very good question. Registered my head.
Table in Desmos. So go to Desmos.
Oh, bathroom.
How do I do a table? Just exit. Do the little plus table.
I'm assuming T is time. Time is always on that x-axis. So it's like
I don't see a red dot. I think it's just graphing it in the. That's the only point you can see in the window that you're in right now. Like if you zoomed out, those are the 3 points.
That's
All right, how do we get quadratic?
oh, it is quadratic.
What button am I pressing? JJ, what button should I press now? Yeah, this little like how would we describe that? A car?
It has a line of 4 wheels.
Oh wow! I definitely
It's the nice.
looked like a crazy music note to me. But,
0.03.
all right, so is a linear regression good? Also, these R values, you see the R values like it says like capital R squared and then the little r. Those, if the closer big R squared and little r to being 1, the better the fit it is, or -1. So this being like 0.0373 is terrible. This is a terrible regression for this. We got a drop-down menu, go to quadratic. Look, R squared is exactly 1. This is a perfect model for these 3 points. It is going through all 3 of them beautifully. Okay, so there's your cutesy equation. So A was 1.858 B is negative 21.888. C is 84.
Oh, because it made the equation for us.
It did.
I,
So we have A, B, and C. And here's where I think that this exam is a little, like, A is a little silly because everyone is probably going to use their calculators to find AI. But what they want you to do to find AII, use the data to write 3 equations that can be used to find A, B, and C. So if we are using 3 equations and this is the model, then we're taking the each ordered pair and plugging them into the model. So you're doing like W at 0. At 0, W should equal 84. But they want you to actually take the input value of 0 and plug it in everywhere that you see a T or an X or whatever. So you'd have 84 is equal to A times 0 squared plus B times 0 plus C. Then do the same thing for 521.
Could you just put it into the...
You have to write down you plugging it into the thing. That's what they're asking you to do. Write 3 different equations. So you have to like write 3 different. It's basically like before calculators, how you would have solved this is by plugging these 3 points into that model. And now you have a system of 3 equations with 3 unknowns, and you could have solved it by hand, but like we have a calculator, so why would we? The part of the equations that you must show is this part. You don't need the W at 5 and 11 and 0, but you have to have an equation. So equations, what's like the most thing that makes it be an equation? What do each one have? Oops, I'm missing. An equal sign. Literally, it's not an equation if there's not an equal sign. So if you just put A 0 squared plus B 0 plus C, and then A 5 squared plus B 5 plus C, and then A 11 squared plus B at times 11 plus C, that's not an equation. You have to include what it's equal to. You also can't just put this part. You can't just have W at 0 is equal to 84. They want to see that you understand how to input the 0 into every place from W at T is A at T squared plus B T plus C. So the most important part, this will give you the points for this question. It's like minutely tedious. You're going to survive. It's an AP exam. Just deal with it and write the equations, okay? And then put it in your calculator or your Desmos and move on with your day.
Oh wow, the graph is like...
Okay, so B, given the data, find the average rate of change. Wow, we're back to that. It's been a while. Average rate of change. What is that a synonym for? Slope. So finding the average rate of change, we're doing slope. And the number of people exercising inside the gym between 5 and 11. They will always give you X values that were from the table. So they're never going to ask you to use X values. Like they wouldn't have put 4 and 10 because if your equation was wrong in part A, they don't want you to use that wrong equation and lose points on the rest of the question. So even if you're like, I don't know how to do A, we should be able to do the slope. Everett, what's the Y value at 11? Well, use your eyeballs and look at the table and find the Y value at 11. We're on FRQ 2, mock number 1. Okay, and then 11 or 5 was what value? 21. So we have 68. Oh, I should have made it 67. That would have been funny. 68 minus 21 over 6. Express your answer in decimals. Just use Desmos. Do 68 minus 21 divided by 6. It's already open for you.
It's 27 over 6.
But we need decimal.
7.83.
So we'll round to 3 decimal places. Here's the key part, because all of this you really could do in your calculator. It says show the computations that led to your answers. If you just write down 7.833 and don't show any work, you will not get credit for this question. The part that you had to show was having the 68 minus 21 over either, you could have put 11 minus 5 right here, or had it as a 6. But you have to, you can't just do this part. This is the same in AP Calc. You have to show that you know how to read something from a table. So you have to take the values from the table, get 68 and 21 and put them over either 11 minus 5 or just put over 6. Do some kind of computation. What they want is to you showing them that you understand things. So the biggest thing that we get talked to as AP readers is that the onus of understanding is on you. It's not on the reader, right? The student has to demonstrate that they understand. I can't be I think that they get it. I think they're trying to show me they understand things. It's not up to me to interpret your understanding. You are there taking an exam to demonstrate your understanding. So you have to show the computations. They don't want you to be able to peek over at the kid next to you and get the right answer, right? They need you to show your work. Okay, and here's the thing where I know that my students all know things and they're going to get BII right. Interpret the meaning in context. So in context of the problem means you should talk about the situation. But what is happening in this situation? We're in a gym, right? And we're talking about the numerator is the number of W at whatever, is the number of people exercising at those time periods. So how to interpret? You would say the number of people exercising. You don't get counted off if you can't spell. You just do the best you can. So the number of people exercising inside the gym between T equals 5 and T equals 11 hours after opening. Is our slope increasing or decreasing? Is it positive or negative? Positive. Is increasing by 7.833 people per hour. The numerator was people. The denominator was hours. So your unit of measure becomes people per. Why does people look so weird right now? Did I spell that right? No. No. I didn't spell it right up here. That's why it looks crazy. Okay. No, and there. That's not how you spell people. P-E-O? I think it's just my handwriting makes it look weird. Okay, whatever. It just looks like it's making my mind boggle. I trust you. You guys probably are better at English than I am. People per hour. I guess that's right. Let's look. They probably said people somewhere up here. Yeah. Oh, would you look at that? Okay. So, I know that was like a lot to write. You have about 15 minutes per FRQ. You will have time to write all of that. Don't rush it and like lose out on points. So the context that's the most important part of this is the number of people exercising. You didn't really have to say inside the gym. That kind of was like unnecessary. But number of people exercising, that's literally the context of the question. So the number of people exercising, and if you do not put the time period, you do not get the points. So you have to say, because the slope, we're doing the slope. So we're taking that graph, where is it? We're taking this graph, and then essentially, how does one copy and paste a table on here? Nope, okay. We're essentially taking this graph of this equation. Oh, I guess I could do the equation. And then only finding, if I delete this and this and do a linear regression, I think I have to delete the whole. Then we're finding the equation of this line. So the equation of that line would have been a very different equation than to the line like between 0 and 5. So you have to have the time interval. If no time interval, no points. Same for my test. Same for the classwork today. So if you don't have the time interval, I'm not going to give you a stamp. You have to say the time interval. And then the last part that's really important is obviously doing the slope. If you don't want to say increasing and you just put 7.8, that's fine. So number of people exercising between 5 and 11 hours is 7.833 people per hour. Great. And here's the last one. This is usually where people either show they understand pre-calculus or they don't. So the average rate of change in I will be used to estimate the number of people exercising inside the gym between 5 and 11 hours, which is what I was telling you. We have to have that time interval. Using the characteristics of the average rate of change and the characteristics of the quadratic model, explain why the estimates using the average rate of change differ from the values given in the model. So in that time interval, look at, I deleted it, I did it kind of quickly. If we deleted the points we didn't use to find the slope, so if I deleted 0, 84, and I did a linear regression, do you see how it can make a little line happen? And every point on that line between 5 and 11, what's happening on all of those points? Are they more or less than the quadratic regression? Here, let's even take a little screen grab, because I don't think you know what I'm talking about. Okay, so here's from 5 to 11. Every point on the line on this interval, whoa, it's so big because I'm so zoomed in. Right, but also just visually look at it. Aren't all the points on that line above every point on the quadratic, right? This point right here is more than the same x value. If I go down, it's like way more than it. So the quadratic model is opening up. How do I know that the quadratic model is opening up? Right, but how do I know it's concave up? Yes, the A value is positive. This makes us open upwards. Because if the leading coefficient is positive, it's going to be a positive x squared would open upward. If the leading coefficient were negative, it would open downward. So since we have a positive Since we have a positive coefficient, it's opening upwards. That makes it be concave up. Versus on the line has a constant. I don't know what we could possibly be typing right now since we're writing things down. Has a constant rate of change. Yeah, that's like a known math symbol is the triangle change. So as a constant rate of change. So using these, explain why the estimates using the average are different versus the ones from the line. So one's concave up. What is the rate of change when it's concave up? Is it positive, constant, increasing, decreasing?
Rate of change is increasing.
Right, so the rate of change now the line has a rate of change that is constant. Now I feel like I still haven't answered the question. Let me think. Okay, average rate of change will be used to estimate the number of people inside the gym in that time period. Using the characteristics, explain why the estimate, I don't think I explained it. Okay. Now, we can see on our graph, our line is what's called a secant line. A secant line is a line that passes through something at more than one point. Tangent is a line that touches at one point. So the secant line is secant to the quadratic and the quadratic is concave up. So all the points on the line between 5 and 11 will be greater than the quadratic model. Because that's like the definition of a secant. If we were, let's just do like another situation. If we had a secant line, was the AP question last year, was you had to like have a secant line explanation. If you had, for example, I know you're probably out of room, but if you had like a quadratic that looked like this, concave down, and you had some line like that, and we're talking about in between these 2 points. So here's another secant line. In the interval between A and B, what would the relationship between the quadratic and the line be then? Would the quadratic be more or less than? More, right? Because at each of these points on the secant line in between A and B, so between A and B here, the quadratic is greater than the line because the line is secant and the quadratic is concave down. When it's what we had, concave up, you have A and B. This is your secant line. Then between A and B, your quadratic is going to be less than the line because the quadratic is concave up and the line is secant. Each year, C is a slightly different question. So C is the only like unpredictable part, or B3, I mean, is the only unpredictable part of FRQ 2. It's either talking about a secant line or it's talking about what's happening beyond 11 and estimating beyond 11. So I think I have another example of that in a second. Okay. 3, this table, accidentally, this table is for the next question. So ignore that table. The gym is open at 7 a.m. and explain how the range of values of the function should be limited by the context of the question. This is another thing that drives me crazy that you guys don't actually read what you're doing. We're applying math to the real world. So the gym is open from 7 a.m. until 8 p.m. What should the range be limited to? When should we stop? 8 p.m. So you need to have the range stop. This is where we're stopping. And this is where we're starting. So your range isn't going from 0 to 13, though. What's the range? The range. This is the domain. What is our range talking about? The y values, right? So we need to figure out what w at 0 is equal to and w at 13. And I think we still have that equation, right, in Desmos? So let's plug it in. Oh. No, because at the more every gym that I've ever been to, when I go at the crack of dawn, has literally people waiting at the door. They are waiting there, ready. My dad was at the door every day at his gym, 5 a.m. And if the person who opened the gym was late, he'd be pissed. Okay, so we got W at 0. Does that 84? And then the gym has to kick some people out, I think, and say, hey, man, we're closing. Get out. At 13, 113.385.
I usually go 8.
You're the person making the person at the front desk feel awkward having to kick you out.
No, I'll let you on my own.
So the context of the question is 84 is less, so it's limited to 100. So it's between 0 and 113, I think. Although, should we look at the maximum? Let's look at our max. Oh, it's a quadratic. So are we going to have a maximum? No, it's going to keep going forever and ever and ever. So we had to stop it. This is the max. It's quadratic, and it would have had 84 right here. And then 113 is when we close. Our model is going to keep going forever, but we have to say this is not existing. The gym is closed. Nobody could actually be inside the gym after 113.38 people. So the max here, because we had to shut it down, was either 113 or 114, whatever one you feel called to. Make sure that show in your work this. Show this number. Because a lot of you guys take responsibility and are like, well, we can't have 0.38 of a person. And you just round it off. You need to show at some point in time that you used Desmos or your calculator and got 113.38, and then say the range is limited to about 113 or 114 people. They'll accept either one.
What if you just say 113.388? Would that not work because you can't have 0.3 people?
They'll probably take it. Okay, so the table is supposed to be down here, so I'm going to copy it over here.
What if it's like amputee, and he's only got like one arm?
That becomes a philosophical question of, is an amputee less of a person?
Well, I mean, physically, that
Feels a little bit discriminatory of you there.
But like physically.
So what makes a person be a person? Mhm. All right, try to do
All their
FRQ. All their limbs. Wow. Okay, I feel like this got a little bit
Well, I'm saying in terms of the problem.
anti-disabled people.
Well, I'm saying in terms of the problem,
a person can still exercise as an amputee.
they can.
They can still go to the gym. They'll have to pay a whole gym membership just like everybody else. They don't pay a fraction, a leg missing portion of a
I
gym
think they
membership.
should because they wouldn't be using
Oh,
that.
you're not
different-
gonna be able to use this leg machine, so I should get a discount on
Exactly. That's what I'm saying.
Yikes. That is a big yikes.
Like if you don't have legs, if you don't have legs, then your gym membership should be like cut in half. That's all the legs that you can.
Cut in half because they're cut in half.
I shake my head at you.
Why? I just want equality.
I think you want equity. The difference between equality and equity.
I don't know what the difference is. What is the difference?
Equity is making people all have access to like on their level, versus equality is everyone's getting the exact same thing.
Yes.
An amputee having equality would be them paying the same membership as you.
Yeah, that wouldn't be fair. They don't need this membership.
All right, let's do FRQ 2, Mock 2 first. So type this into your Desmos. Go. This should be quick. Typing this one into Desmos.
My computer was dead yesterday. It made me so mad because I charged it and then it just died in my backpack. Oh, it's the same. What is this? Oh, I forgot
Mhm.
to. Wait, I don't know.
We're on the last page of the notes. The table got like stuck on the last page. Oh, I think though, yes, I do have some receipts on here. Well,
Is there a table?
oh right, I remember that happening and being like, I should change that for next year. And then I didn't remember that I needed to change it for next year. All right, people, let's go. This should be fast.
Oh, shoot. The table would just be.
I don't know what you did there. Maybe refresh. Yeah, try to go past it.
Oh, it is a table. So it'd be 0, 14,307. And then it'd be 13. 35,000. Bam. Is it linear? Not 2 points, bro.
Try to do the whole thing. I believe in you.
What is the regression? I'm so confused.
What would the regression be? What is it asking for?
A, B, is it?
Huh? Wait, no, we are doing this one.
Not that one. Oh, this is a different stuff. Attempt to That's a quadratic. Yeah.
All right, what do we get for A on this one?
The three equations. Oh, for that one.
AI.
And 0.716.
Sierra, you don't have to like copy it. Just go where it says equation and in the quadratic. Great. Oh, you're renaming it? Okay. Did we get negative 0.717? If you didn't get negative 7.717, you're probably doing the wrong question. B.
So when it's just as for the equation, we don't actually have to solve the equation.
Right, you just have to plug in.
Well, for at least part one.
All right, keep going. Go to B. I think B, I, and 3 is probably our hardest one. So try to do B.
Miss Russell, I'm kind of confused about to write the three equations.
So taking these, this is the T value, and plug it in where there's a T,
Mm-hmm.
and that's L at 4, or L at 0 is 4. So you're saying 4 is equal to A times 0 squared plus B times 0 plus C.
Oh, okay,
And you do the
so
same thing with 5.
it's like 21 equals,
Mhm.
and you just write those. You don't have to like.
You don't have to actually solve it. I mean, you could, but why would you?
Okay, and then for this one, you just look at the regression.
Mhm. Graham, what'd you get for the slope for B?
Not good.
Let's go. I'm doing a lot of talking over there. Not a lot of mathing.
How do you, wait, how do you see his?
I can hear you. Ellie, let's go. We need to practice on our own.
Wait, how do we see what it is? That was 5. How do I put that into decimals to see what is under F?
Rename it to L. Mm-hmm. Huh?
That's 3
Interpret.
Ah, there it is.
Interpret.
Oh, that's
Any question in here can tell you, but not enough.
I'm just like dyscalculated, you know. It's like dyslexia for me. I was calculating. Like I'm just like I was
All right, what's the slope for B? Negative 2.3 is not going to be enough decimal places. Are we just writing negative 2.33 for the slope? Yes, 14 minus 21 over 8. Is it 8? Yeah.
So, as decimal approximations, would I go with the 999 value or like the 14 value?
Depends. What's after the 9?
9.
So then 14. Okay, so on your table to do B, the average rate of change in I to estimate 7 hours. Show the computations that led to your answers. You could do it 2 ways, but here's the fast way to do it. You have the points. And what points did we use to find? 5 and 8, right? So we should use the same points. At 5, the y value was 21, and then at 8, is that the right y value? Okay. At 8, the y value is 14. It's trying to give you, if you're doing the slope, it's trying to have you write the equation of a line. So if you do the linear regression between 521 and 814, then you're going to have, isn't that the right slope we just had? And so then you can copy that equation and name it something, I don't know, L for line at X. Use that equation to then find, you're trying to write the equation of a line, but only between 5 and 8, and approximate it at 7. Then do L at 7. 16.3. So in this one, a slightly different question. We're using the average rate of change we just found. So we're basically trying to estimate the number of cars. Estimating the number of cars, you're trying to write a linear equation. Between 5 and 8. So our equation, we can just do a regression, a linear regression between. So a linear regression gave us negative 2.333x, and I don't remember the other number, plus 32.6. Repeating. And showing the work, the computations, and I would just say, I guess we called it line, but whatever, y at 7 and plug in, pretend like you actually plugged in 7. Was it 16.333, I think? No, yep, another 3. So when it says use the average rate of change, it's saying that when you do the average rate of change, that's the slope, and it's the slope of a line. So because it's the slope of a line, then you're using the equation of a line through that point. So that we can just quickly get an equation of a line by doing linear regression. You would have gotten the same equation of a line if you did point slope. So you could also do point slope as well, but why do more work when less work do trick? You know what I'm saying? So linear regression, so much easier. Just delete the extra point. Make sure on this that you delete, before doing the linear regression, delete the other points. So we're deleting 0, 4. Otherwise, it's going to screw up your regression because you're not actually trying to find the slope of the line at 0, 4. So that's going to like tilt the line down more. All right, the average rate of change found in I can be used to estimate the number of cars in the parking lot. Bigger, so this is different. This is the other situation I was telling you about. More than 8 hours. Will these estimates be less than or greater than? So think about what was happening. What way was our quadratic facing before? Was it opening up or down? Down. It was concave down. You had this quadratic. And then we just found this line of negative 2.37 whatever x doing something like this. The line we just found, this point is at 8, this point's at 5. So everything more than 8. Will the find the average rate, will the estimates found using the average rate of change, so found using the line, be less than or greater than the quadratic model? So every point on this line more than, are they more than or more than 8? Are they more than the quadratic or less than the quadratic? To me, it looks like the line is above the quadratic forever.
Oh.
When we're talking about where t is greater than 8, we're over here. We're like bigger. So the line t So the average rate of change will be greater than the quadratic model when t is greater than 8, since L of t is concave down and the line is secant. So outside of we're not between 5 and 8. Between 5 and 8, the quadratic model is going to be more than the line. We're talking about everything beyond that, where the line is going to actually be, in this situation, above. So the line is bigger than any of these points. Do you see how it's above? Line is higher than quadratic. So a lot higher. Yes? Does that make sense? Okay, then C, appropriate prediction, number of cars in the parking lot. That's at least 0. Based on this information, what's the largest value of t for this model? So we're talking about where the number of cars is 0. What does that actually mean? Number of cars being 0. The x-intercept. And we have a model that's doing like this. How would you find the x-intercept on your model? Just touch the x-axis, right? There is going to be technically an x-intercept over here. Will that make sense in context of the question? Being negative? Right, so we're not going to have any negative x-intercepts. Our x-intercept is at 10.286, 0. So about 10 hours after opening would have our parking lot being 0. I guess technically is the larger. If there was a smaller one, you want to go further. Larger x-intercept. All right, so on the classwork, which we probably don't have a ton of time to do, most of these are pretty fast though. You'll be doing page 2 and page 4 because page 1 and page 3 we've already done, and I should probably make sure I edit that for next year so that way I don't do this again and waste all the paper I just wasted. So page 2 and 4, the back of both pages. I think in the next 5 minutes you could at least finish page 2.
Oh, yeah. That one was good. I like the
Let's go, let's go. You can get a stamp today if you work.